I just want to be liberated. If I've instigated, I'm sorry. Lower that. Oh yeah, brother. And I got all the VODs up. But I gotta watch this shit. I'm almost done with this bullshit.
Mike. In this tutorial, I'm going to show you guys how to build an exponent function in C Sharp.
This is
So an
super
exponent
easy.
function is basically a function where we can pass in two numbers, a base number and a power number, and it'll take the base number to the power number. So essentially, it's going to, like, if I passed in a 2 and a 3, it would give me 2 raised to the third power, right? Or if I passed in a 4 and a 7, it would give me 4 raised to the seventh power. That's essentially what we want to write in this tutorial. So I'm going to come down here below my main method, and I'm actually going to create this function. So I'm just going to say static, and we're actually going to return a integer. So why don't we just have this accept integers? We'll just keep it simple. And I'm just going to call this get pow. So this will basically like get the power, and I'm going to make some open and close curly brackets. And in here, we're going to accept two parameters. So the first is going to be an integer base num, and the second is going to be an integer pow num. So we'll basically take the base num and raise it to the pow
Fucking
num, right? So if base
hilarious.
num's 2 and pow num's 3, then we'll do 2 cubed, right? It kind of makes sense. So this is going to be a cool little method, and it kind of poses an interesting challenge because we don't know what base num and pow num is, right? If we knew what power number was, for example, if we knew power number was 2, then I could just say base num times base num, right? I could just square base num and we'd be good to go.
Just gonna make a
But I
fucking
don't
for loop
know what
guy.
pow num is, so I don't know how many times I need to multiply base num by itself in order to get the answer. So this kind of poses an interesting challenge. And I'm going to show you guys how we can use a for loop to solve
Yeah,
this challenge.
obviously,
So
nigga.
the first thing I want to do is just create an integer, and I'm just going to call this result, and I'm just going to set result equal to 1. And then eventually what we want to do is return result. So we want to modify result enough where it represents base num taken to pow num. Okay? And what we need to do is we need to keep multiplying result times base num pow num times. So let me show you guys. We can create a for loop, and I'm just going to create a simple for loop. And remember, when we're creating for loops, the first thing we want to do is create a variable. So I'm just going to say int I is equal to 0. And I'm going to start this off at 0. And then what I want to do is create a looping guard, so a condition. In other words, we're saying we want to keep looping as long as this condition is true. So I want to keep looping as long as I is less than pow num. And when I say this, this is basically telling C sharp that I want to keep looping pow num times. So if pow num is equal to 3, we're going to execute this loop 3 times. If pow num is equal to 5, we'll execute it 5 times, etc. And the last thing we want to put inside of this for loop is going to be something we want to do after each iteration of the loop. So I'm just going to increment I. And this is a very, very, very simple for loop. So we're looping through here pow num times. So like I said, if pow num is 2, we'll go here through here 2 times. And every time I go through this loop, I basically just want to multiply result times base num. So I can say result is equal to result times base num, just like that. So the first time we go through this loop, result is going to be equal to 1, right? So the first time we go through, result's going to be equal to 1. So now result will be equal to 1 times base num, right? The first time through, result's going to essentially become equal to base num. The second time we go through, results equal to base num, right? So we're essentially multiplying base num by base num, in other words, base num squared, and storing it inside of this result variable. And we're going to keep doing that through each iteration. So if we go through this loop 3 times, then result is going to have the value of base num cubed. If we go through this loop 5 times, result will have the value of base num taken to the power of 5, right? And then down here, we can just return result. So by using this for loop, we're actually able to figure out what the answer is. So up here inside my main method, let's go ahead and run this. And I'm actually going to print out the answer. So I'll just say console.write line, and we're going to write the result of get pow. So why don't we try to do like 3 squared, right? So we'll pass in 3 and 2, and I'm going to go ahead and run this program. So we should get the result of 3 squared, which is going to be 9. And you can see over here we get 9. Now, I just want to point out this this get pow method is only going to work for positive number powers. So we're not going to be able to do like 3 and -2. That's not going to work down here. But we can do positive number exponents. So I could say like 3, 2. Why don't we try like 4 and 3? So this is going to be 4
I'm not
cubed.
going to try this.
So we should get
I
64.
already did
And yeah, we get 64. All
last
right,
time.
so
This
it looks like
just
this
the next
method's
video
working.
online.
So once again, I'll just walk you through what we did. This get pow method accepted 2 parameters, base num and pow num. So the goal was to take base num to pow num. We created this for loop over here, and essentially all I did was I said I equal to 0, and we're going to keep looping as long as I is less than pow num. And what that means is we're going to go through this loop pow num times. So if pow num was 5, that means we went through this for loop 5 times. And every time we went through this for loop, we multiplied result, which was initially equal to 1. We said result is going to be equal to result times base num. So the first time through the loop, result was equal to 1, so we ended up getting result is equal to 1 times base num. So we got base num. Second time through the loop, result was equal to base num. So we said result is equal to base num times base num, essentially. The third time through the loop, result was equal to base num squared. So essentially we were saying result is equal to base num squared times base num cubed. And that's essentially what we did. And that was actually enough for us to get base num taken to pow num. So it's a pretty simple method, although it is a little bit complex because we use this for loop. So what you should do is play around with this method and, you know, write it on your own and see if you can really wrap your head around what's going on here. Hey, thanks for...
Yeah, I have a whole bunch of other shit. Like I have all this entire test script that has all these other bullshit that I've been testing with. I already have for loop stuff over here and stuff that I was messing around with yesterday. I just take a back step because it's the next video. See? And now the next video is 2D.
Why should you use Miro?
This is
well,
what I'm
when
really...
you draw on a whiteboard, no one sees it. With Miro, you plan together in real time from literally everywhere. And it's not...
Hey, welcome to Giraffe Academy. My name's Mike. In this tutorial, I'm going to show you guys how to use two-dimensional arrays in C#. A two-dimensional array is basically a situation where we have an array, and every element inside of that array is itself an array. So essentially, we're building like a little matrix structure inside of our program. And I'm going to show you guys how we can do that. It's actually pretty simple. So if we want to create a two-dimensional array, we can do it just like we would a normal array. So I'm going to create an array of integers, so we'll just say int. And now what I want to do is I want to make an open and closed square bracket. And inside of this open and closed square bracket, I'm just going to put a comma here. And basically this is telling C# that we want to have a two-dimensional array. And I'm going to give this a name. So I'm just going to call this number grid. And I'm going to go ahead and set this equal to something. So now what we can do is we can actually fill this array with a bunch of different elements. So I'm going to make an open and closed curly bracket. And then I'm going to make a new line. And down here, we're actually going to be able to populate this array with elements. So if I was making a normal array, I would usually just put in like a bunch of numbers. So I'd say like 1, 2, 3, 4, etc. But when we're making a two-dimensional array, all of the elements inside of this array need to be arrays. So themselves, they have to be arrays. So the first element has to be an array, and the second element would have to be an array, and the third element would have to be an array, etc.
Sweet. Good.
All of these elements have to be arrays. And then I could give these values. So I could say like 1,
taking hella notes.
1, 2, and then down
it's
here.
It's all notes on fundamental stuff. So like this bullshit. I've just been taking all these notes. This is more Unity notes up here. This is where I took a back step to just C#. Because the issue is I was making stuff in Unity, but I didn't really understand what my code was saying. I just knew what it did. And I was like, I can't do this. So that's why I ended up taking this C# shit. Because of what I'm going to do now is fully watch this C# little like 4-hour class thing. And then I'm going to jump into my Unity code, right? With like the new lens of understanding all the fundamental shit that I've just been using, but not truly understanding. Like, obviously, I understand what it's doing a little bit, but it's like, I want to like know what the fuck's going on.
And we could say 5, 6. So basically now we have a little matrix of numbers, right? Not only does the number grid have 3 elements, but each of the elements inside of the number grid has 2 elements inside of it. And this is a two-dimensional array. So let's look at how we can actually access some of these elements. What I can do is I can come down here and I'm just going to say console.writeLine. And if I wanted to, like, for example, let's say I wanted to print out this element over here. I can just refer to the name of the array. So I can say number grid. And then I'm going to make an open and closed square bracket. And in here, I'm going to put 2 numbers. So the first number I'm going to put is going to be the element inside of the array. So it's going to be like, this is the first element, this is the second, this is the third, or this is element at index position 0, this is element at index position 1, index position 2, etc. So I'm going to put a 0 because we're trying to access this 1 over here. And then I'm going to put another 0. So I'm just going to put 0, 0. And that's referring to row 0, column 0. Now, when I run this program, it's going to be able to print that out. So you'll see we're printing out 1, we're printing out that element over there. Let's say that I wanted to access this 4 over here. Well, this is going to be row 0, 1. So I'm going to put a 1 right here. and then it's going to be 0, 1. So it's going to be 1, 1. And now when we print this out, we should get a 4, which we do. So that's essentially how you access those elements inside the array. And this works exactly like it does with a normal array. So if I wanted, like, I could modify one of these values. I can do everything that I would do in a normal array. And that's kind of the basics. This is a structure that you might not use all the time, but when you need it, it's extremely useful. And in addition to 2 dimensions, you could also have like 3 or 4 or 5 dimensions. All you have to do is just put more like commas over here. There's also a situation where you might not know how many elements you want to go in there initially.
Arrays of arrays of arrays of arrays.
And you could actually just like declare one of these. So I could say like int, and I'll make a 2-dimensional array, and we'll just call this like my array. And if I don't know what elements I want to put in here initially, I can actually just say equals new int, and then over here I need to give this some information. So I would have to say like 2, 3. And this is basically telling C# how many rows and how many columns we want to have. So this would mean there's 2 elements, and then each of those elements has 3 elements inside of it. So that's another way that you could do that. And then you could just manually like insert the elements. Hey, thanks for watching. If you enjoyed the video, please leave a like.
That's retarded that
and then
did that.
You could just manually like.
What do you mean manually insert? Like, where would you do that? You would just make. You'd have to just my array equals. There's no way that that's how that goes, right? Yeah, I didn't think so. Is it int array? No, this looks like it. Oh, I gotta put a. This is like a little sequel. There you go. Oh, like my array 1, 2 equals 3, right? I see what you're saying. Wow. There's no way that this is true. Yeah, do your thing, dude. I'm in here. The second array, the second spot. Oh, shit, that's right. 1, 1. You say no because you love those kids. Get some fucking winged dingus. It just sucks that it's cold as shit in the mornings, to be honest. Like I just prefer running in the morning, dude. This. You're like, hey man. 19. Easy money.
Like insert the elements.
Comments.
Selling out is one of the best things that could happen to any merchant. It's a really good feeling.
Hey, welcome to Draft Academy. My name is Mike. In this tutorial, I'm going to show you guys how to use comments in C#. Now, a comment is basically just a special line or block of text in our program that's going to get ignored when we run the program. So comments are really useful for leaving little notes or comments inside of your program. And a comment is essentially just a line of code that's meant for humans and not meant for the computer. And these can come in handy. So I'm going to show you guys basically how these work and what we can do with them. If I wanted to create a comment, I could just come down here and type 2 forward slashes, just like that. And now you'll see that the text in my text editor has changed color. It's now this green color, and that's basically signifying that we have a comment here. So like I said, a comment is a little line or a little block of code that's actually going to get ignored by C#. So when I run my program, anything that I have inside of this comment is just going to get ignored. The comment is for the programmer, so it's for me or it's for another developer who comes in and is reading my file. So I could leave like a little note here. I could say like a to-do, like, you know, maybe this block of code needs to be done. Or I could even come in here and like describe a line of code. So I could describe this line of code over here. I could say like this prints something out, etc. You could also take these comments and put them after a line of code. So I could come over here and say 2 forward slashes, and you could type out, you know, a comment, whatever. And this is what we call a single line comment. So a single line comment is a comment that can only be on one line. So if I was to make a new line, you'll see down here, this is no longer a comment. And you'll see it's actually throwing an error because the program is trying to render it as actual code. But in addition to single line comments like this, a lot of times you're going to want to have comments that are span multiple lines. One thing you can do is just make multiple lines like that. And you'll see a lot of developers do stuff like that. You can also use a starting and an ending tag. So you can type in a forward slash and a star. And now everything that comes after this forward slash and a star in our file is going to be considered a comment. That is until we end it off with another star and a forward slash. So I can say star, forward slash, and now you'll see only the stuff that's in between these two little tags is going to be considered a comment. And these can go on multiple lines. So those are basically the two types of comments that we can use. And really a comment is extremely open-ended. I mean, there's no wrong way to use a comment. It's really however you want to use it. And I do want to show you guys one other way these can be useful. So let's say that I'm writing code and, you know, I want to try and run my code without a certain line in it. So maybe I'm like, you know, have a program and I think one line might be causing it to break, or I just wanted to see what it would look like without a single line of code. Well, one option would be to remove that line of code. So for example, I could take this line of code. Maybe this is a line of code that I think is causing my program problems. I could delete it and then I can go ahead and run the program, right? And then nothing gets printed out. But here's a problem. When I do that, I have to actually like physically remove the line of code. Instead, what I could do is comment it out. So I could just put a comment in front of this. And now this whole thing is basically going to get ignored by C#. So I can run the program and we're still going to be running it without that line of code, but I don't have to physically delete it from the file. And that just allows me to keep track of it a little bit better. And, you know, I can still have it there. It's still taking up space in the file. It's just going to get ignored. So that can be a really useful way. So really, I'd say comments, you know, are basically used for two things. The first is like writing out little messages or notes, either for yourself or for other programmers, or for commenting out lines of code. And you'll see people do both of those. And they're both really awesome. So like I said, comments are pretty much open-ended. You can do whatever you want with them, but I'd say those are the two most common use cases. Hey, thanks for watching. If you enjoyed the video, please leave a like and subscribe to Draft Academy to be the first to know when we release new content.
Man, trying to tell me how to use the fucking goddamn comment, bro. Hello, doggy, you fucking bipolar son of a bitch. He's like, pet me now. Now it's time for me to get pet. See, look at this. Look at Oliver. It's bedtime for Oliver now. He's allowed to sleep now. I'm a horny one.
Our mission in Coding Dojo is about redefining what's possible in our students' lives. If you are
Hey, welcome to Draft Academy. My name is Mike. In this tutorial, I'm going to show you guys how to use exception handling in C#. Now, a lot of times when your C# programs are running, there's going to be certain things that can go wrong. And generally, when those situations occur, C# is going to throw what's called an exception. An exception basically just tells you that something happened in your code that C# couldn't handle. And whenever an exception gets thrown, generally the program crashes. So there's a lot of situations where something might happen in the execution of the program, an exception is going to get thrown, and then the program's going to terminate. And sometimes you're going to want that to happen. Sometimes when an exception gets thrown, you're going to want the program to terminate because you're going to want to know what happened. But a lot of times, especially if you're writing a program that's being designed to run for, months and months at a time, you're not going to want an exception to crash the program. In other words, you're going to want the program to be able to keep going when something wrong happens and an exception gets thrown. So I'm going to show you guys the basics of working with exceptions. We're also going to talk about handling exceptions and the different scenarios where an exception is going to get thrown. So down here, I have a basic program written out. And this is a very simple program. Essentially, all it does is it gets two numbers from the user, and it takes those numbers and it divides them. So you see over here, I have console.write. I'm asking them to enter a number. And then I'm taking whatever they entered, and I'm converting it into an integer, and I'm storing it inside of this integer variable. And I'm doing that for both of these numbers. Then down here, I'm just writing out the value of dividing both numbers onto the screen. So there's two major things that we're doing here. The first is we're converting this string into an integer using this convert instruction. And then down here, we're dividing the two numbers. And I'm going to show you guys how we could actually enter in information to this program that will cause exceptions. So let's go ahead and run this. And I'm just going to click start. So over here, I'm going to enter a number. So why don't we enter in a 5? And now I'm going to show you guys one way that an exception could get thrown. So remember, we're dividing these two numbers, and you can't actually divide a number by 0. So just by basic math rules, if we have a whole number like this, it's impossible for me to divide it by 0. So essentially what I'm doing here is I'm asking the computer to do something impossible, right? I'm asking the computer to do something that it's not going to be able to do and it's not going to be able to handle. When I hit enter and I ask the computer to do this, it's going to throw an exception. In other words, the computer is going to be like, hey, I can't do this. Like, I can't divide these two numbers, so the program's going to terminate. So you'll see when I hit enter that this little screen goes away and this exception pops up. So it says exception unhandled, system.divide by 0 exception, attempted to divide by 0. It's basically telling us what went wrong, right? It's saying, hey, you tried to divide by 0. That's illegal. You can't do that, and we can't handle that. So basically, it's throwing this exception. So you can just come up here and click stop debugging, and that'll make that go away. I'm going to show you guys one other way we can break this program. So if I put a number in here like a 4, that's all well and good, right? But remember, we're converting whatever is up there into a number. So if I was to type in like a G, this isn't a number, right? G is not a number. It has no numerical value. So the program isn't going to be able to convert G into an integer, even though I asked it to. So when I hit enter, another exception is going to get thrown. This time, we're getting a format exception. It says input string was not in correct format. In other words, we asked you to enter in a number and you entered in a character. The program can't handle that, so it breaks. That's another example of an exception. So the question becomes, what do we do about this, right? Our program keeps throwing these exceptions, so how can we handle that? Like, if the user enters in a letter instead of a number, I don't want the program to terminate. I want to be able to do something else. Like, I want to be able to yell at them and be like, hey, you entered in the wrong thing. I don't want the program to terminate. Or if the user tries to divide by 0, you don't want the program to terminate. You want to tell them that they entered in an invalid number. So if we want to do that, we can actually do something called exception handling. Exception handling is basically the process of catching these exceptions. So we're basically going to tell C# like, hey, there's some code over here that might throw an exception. If it does, we want you to catch it. And instead of crashing, we want to be able to handle it. And I'm going to show you guys how we can do that. So we want to use something called try catch blocks. So I'm just going to type out try and open and close parentheses, curly bracket. And then down here, I'm going to type out catch. And again, an open and closed curly bracket. So try catch blocks work like this. Any code that we think is going to break the program, for example, the code down here, we can put inside of these try blocks. And if that code does indeed break the program, then instead of the program terminating, the program is going to go down here into this catch block and it's going to execute all of the code down there. So what I want to do is take all of my risky code, in other words, all of this stuff, and I can place it inside of these try blocks. So I'm just going to paste it inside of here. So now all of this code that potentially would break the program is inside of this try block. So what I want to show you guys now that I have this catch block over here, I can just do like console.write line, and over here, I'm just going to print out error. So essentially what's going to happen now is if any of this code causes an exception, we're going to come down here and print out this. So let me show you guys. I'm going to go ahead and run this program, and it says enter a number. So let's do the 0 one again. So now I'm going to hit 0. This should break the program. But now instead of breaking the program and causing an exception, we just print out error. So it's kind of like a backup system. And what we can also do is we can get more information about the error that occurred. So I can say catch I can make an open and close parentheses, and then I can say exception, and I can just call this E. So I'm basically saying that this catch block is going to take an exception parameter, and we're going to call it E. If I came over here now, I could basically print out E, and I could say E dot message. And this is going to tell me what went wrong. So now when I run my program and we can do that 0 division, I'll say 5 divided by 0, and it's going to tell me what went wrong. It's going to tell me you attempted to divide by 0. If I did the other error, so for example, if I entered in a letter like G, now it's going to tell me input string was not in correct format. So it's able to catch the error that happened, and by saying exception E up here in these parentheses, we can actually get the error message just like that. So this is a really great way to kind of stop our programs from terminating. But here's the thing. There's all different types of exceptions that can get thrown inside of our programs, right? And all I have down here is one catch block. So no matter what exception gets thrown, we're always executing this same code down here. But let's say there was a situation where when the 0 division error occurred, you wanted to do one thing, and when the input error occurred, you wanted to do a different thing. Well, you can't really do that because we only have one catch block. But what we can do is we can actually define specific exceptions that we want to catch. So down here, instead of saying exception, I can actually specify a specific type of exception that I want this catch block to catch. So before we were getting a divide by 0 exception, so I can put this in here, and now this is only going to catch a divide by 0 exception. So if I was to run my program and we did the divide by 0, I'll say 5, 0, you'll see it's able to catch it. But if I was to do that invalid format, if I came over here and I said like 6 and then I said a G, it's not going to be able to catch that. So down here, we're getting this format exception, right? And basically, it's not being caught because we didn't specify it down here. This catch block is only going to catch divide by 0 exceptions. But what we can actually do is we could make another one. So I could say catch, and in here, I'm just going to type in format exception. And now this is going to be able to catch any format exceptions that occur. So now I could say console.writeLine. And again, we can just print out like e.message. And so the idea is that instead of just printing out e.message, you would do something different depending on the error that gets thrown. In our case, though, we're just going to say e.message. So now when I get that format exception, if I say like 5 and then G, it's going to say input string was not in correct format. So it's able to catch both of those. And that's essentially what you want to do. So what we were doing before is we just had like catch, and we were just kind of catching any exception under the sun. But now we're catching individual exceptions. And this is actually a better way to do it because we're able to account for each of these situations, right? When the user divides by 0, we could print out like, hey, you divided by 0, like watch it. If they have a format exception, then we could do something else. Like maybe we could prompt them to enter that input again, or we could do something else. And so being able to have these multiple catch blocks is extremely useful. There's also one more thing I want to show you guys, which is called finally. So down here, I could just type out finally, and I'm going to make an open and closed curly bracket. And any code that we put inside of this finally block is always going to get executed no matter what, right? No matter what, it's going to get executed. So for example, up here, this code, like if the user enters in an invalid number, like if they enter in a letter here instead of a number, this code won't get executed, right? Because we threw the exception and we broke and we came down here. But sometimes in your programs, even if something throws an exception, you're always going to want to execute something, and that code can go down here in the finally block. But you don't always need the finally block. That's kind of optional. So really, this is just how we can handle different errors in our program. And there's a bunch of different exceptions. If you just go online and search for like C# exception list, you'll find a bunch of these different exceptions. And this really just makes your programs more durable. Like before, this was a very fragile program. If I entered in a letter instead of a number, like it would just crash and burn. But now we're actually able to handle all those different situations using these try catch blocks.
Yeah,
so these are extremely.
You can't do anything else after this program cheek.
Useful. And anytime you have code that's a little
Okay. Boom.
Hey, welcome to Giraffe Academy. My name is Mike. In this tutorial, I'm going to show you guys how to use
God
classes
damn.
and objects in C#. Now, classes and objects is actually a big subject, and there's a lot for me to talk about in this particular topic. But this video is just going to be a very basic introduction into what classes and objects are and how we can start using them in our C# programs. Now, in C#, we're going to be dealing with all types of data. And a lot of times when you're writing your programs, you're going to want to work with and represent different things in your programs. And by default, C# gives us a bunch of different data types that we can work with. So in C#, we can represent things like text. So we can use strings to represent text. We can represent characters. We can represent whole numbers with integers. And we can represent decimal numbers with things like doubles and floats, right? We can also represent true and false values with Boolean variables. But here's the problem is with just those limited data types, we're not going to be able to represent or model everything that we'd want in our programs. In other words, there's a lot of things in the real world that can't just be represented using a string or a number or a Boolean, right? I mean, think of something like a phone, for example. Like imagine I wanted to represent a phone inside of my program. Well, I can't represent a phone with like a string. You know, I can't represent a phone with just a number. Like a phone is a complex entity in the real world. And I can't sort of break it down into just one single like string or number, right? I can't represent it using just one of those data types. And that's kind of one of the limitations that you're going to encounter is like you can't represent everything just using one of these data types. So what I want to talk to you guys about today is something called classes and objects. And classes and objects essentially allow you to create your own custom data types. By default, we're given things like strings, numbers, and Booleans, but I could actually create my own data type that would allow me to represent something that I wanted inside of my program. So generally what we'll do when we want to create a data type in C# is we'll create something called a class. And a class is basically just a specification for a new data type. So I could create a class for a phone, or I could create a class for like a water bottle, or I could create a class for a keyboard or a computer, and then I could represent all those different things inside my programs. So classes are basically used to model real world entities inside of our program. So I'm going to show you guys how we can build a class in order to do that. The first step when we want to build a class is you want to open up your Solution Explorer over here. In my case, it's just over here on the right side of my screen. And I'm going to go down to my project. So I'm over here in my draft project. And when I want to create a new class, I can just right click and I'm going to go down to Add. And I'm just going to click New Item. And then over here, we should get this little menu that pops up and it says Class. This is the first one right up here. So I'm going to select that. And then I can actually come down here to the bottom and give this a name. So I'm going to go ahead and name my class. And generally, when we're creating a class in C#, you want to name it with a capital letter. So in this situation, I think we should create a class for a book. So let's say that I was writing a program. Maybe this was a program for like a library or a school bookstore, and I wanted to be able to represent a...
Learn to code online in less than a year. Discover the San Diego State University software development
book inside of my program. So I want to create a book data type. So just like I create a string or I create an integer or I create a Boolean, I want to be able to create an actual book inside of my program. So I'm going to create a book class and I'm just going to call this book.cs and I'll hit enter. And you guys will see over here that another file has been added to our Solution Explorer. So now we have this book.cs file.
Does my C# have a Solution Explorer? It does. Just says assembly.
And And you'll notice that this is pretty much laid out exactly like the other one. So exactly like this program class that we were using over here. And it's basically just like an empty class. So remember what I said, a class is essentially just a specification for, or really it's like a blueprint for a new data type in our program. And one of the cool things about C# is it actually allows us to, specify a custom data type. And essentially what we want to do is we're going to be creating a complex data type. So a string, for example, is a data type, right? And all it is just plain text. A number is a data type, and all it is just, a number, right? We have integers, we have floats, they're whole numbers and decimal numbers. But when we create this book data type, it's actually going to be composed of all of those other data types. So inside of here, we're going to define a series of attributes. And these attributes are basically going to describe what a book is inside of our program. And that's generally what you want to do when you create a class. You're going to take a class and you're going to give it a series of attributes. And like I said, those attributes will kind of define what it is. So I have this book class, and I want to think about what are the different attributes that are going to allow me to represent a book inside of my program. And what I want to do is I want to actually create variables for each of those. So let's think about this. What are the different attributes of a book? Well, I can think of the first one is going to be title. So over here, I'm going to say string title. And before I say string title, I'm going to say public. So I want to say public string title. And I'm actually going to make this lowercase. So that's one attribute that we could store about a book. What's another one? Well, let's think. We would also want to store the book's author. So I can say public string author. And let's just try to think of one more. So I think one more good one might be the number of pages. So I'm going to say public int pages. And all of these different variables that we're declaring over here are called class attributes. And these are essentially pieces of information that are describing what a book is in our program. So I'm essentially modeling the book data type. I'm creating a blueprint for the book data type. I'm saying that inside of our program, a book is going to have a title, an author, and a number of pages. So this is a specification. It's a template. Now what I can do is I can go off to my other program and I can actually create a book inside of my program. So just like I create a string, or I create an integer, or I create a double or a Boolean, I can create a book. And I can store it inside of a variable, and we can actually create something called an object, which is going to be a actual book inside of our program. So I'm going to show you guys how we can do that. I'm going to save this file, and I'm going to head back over to program.cs. So this is like the file that has our main method over here. And I want to show you guys how we can create a book now. So if I wanted to create and represent an actual book inside of my program, since I created that class and I defined what a book is, I basically defined the book data type, I can actually do that. And I can create something called an object. And an object is an instance of a class. So when we created the class, we created the template for what a book is. When we create an object, we're creating an actual physical book inside of our program, right? So over here, this class specified like a title, author, pages, right? This is a specification for what a book is. When I create a book object, I'm creating an actual book with an actual title, actual number of pages, and an actual author. So I'm going to show you guys how we can do that. The first thing I want to do is I'm basically going to create this like I would a normal variable. So the first thing I'll do is specify the data type. And in our case, we're going to create a book using the book data type. So just like if I was creating a string, I would say like string, whatever is equal to whatever. Here, I'm just going to say book, and we're going to do the same thing. So I'm going to say book. I'm going to give this a name. So why don't we just call it book 1. And now what I'm going to do is set it equal to new book and an open and close parentheses. And this is how we can create what's called a book object. This is essentially an instance of a book. So this is like a physical book inside of our program. So the class is a specification. The class tells us what the book data type is. An object is an actual instance of that class. All right, so hopefully that makes sense.
As we teach our students week after.
So now I've actually created this book called Book 1. And we can use book one over here just like a variable. I mean, it's essentially just a variable that's storing a book object. So remember, the book has all of these attributes, right? So a book can have a title, a book can have an author, and a book can have a number of pages. So when we create our book, we want to give it all of those attributes. So what I can do is I can say like book one dot, and now I can access the attribute. So I could say book one dot title, and I can actually give this a value. So let's say that we wanted to create an object that would represent one of the Harry Potter books. So I could say book one dot title is equal to Harry Potter. So now the title of my book is going to be Harry Potter. Let's come down here and we'll say book one dot author, and the author of the Harry Potter books is J.K. Rowling. So I'm going to say book one dot author is equal to J.K. Rowling. And then finally down here, we're going to say book one dot pages. And let's just say that this Harry Potter book has 400 pages in it. So what I did was I created a book object, which is an instance of the book class, and I was able to define all of the pieces of information about this book. So I defined what the book's title was, I defined what the book's author was, and I defined how many pages the book had. And so now what I can actually do is I can work with this piece of information. So I could say like console.writeLine, and over here I could print out some attributes of the book. So I could say like book one dot title. And now when I run my program, it's going to print out the title of the book we just created. So it should print out Harry Potter. I could do the same thing for the other attributes. So I could say like book one dot pages. And now we're going to print out however many pages book one has. So we're going to get 400. So essentially, I'm creating here a book, right? I defined the book data type in that class, and now I'm creating an actual book inside of my class, which we're calling an object. And what's cool about these objects is I can create as many objects as I wanted. So I could come down here and I could actually make another object. So I'm going to copy this guy and I'm actually going to paste it down here. And instead of being book one, I'm going to change it to book two. So this is going to be book two, book two, book two, book two. So let's start giving this some different information. Let's say this object is going to represent one of the Lord of the Rings books. So I could say Lord of the Rings, and then the author is Tolkien. And let's say the Lord of the Rings has like, I don't know, 700 pages in it. So now I have a book up here called book one, which is representing the Harry Potter book. And then I have another book down here, book two, which is representing the Lord of the Rings book. And I'm actually able to have an actual book in my program, right? So I'm able to represent and store and work with and model a book inside of my program. So down here, I could do the same with book two. I could say like book two dot author. And now this is going to print out the author of book two. So you'll see over here, we get Tolkien. Now, I want to bring up one point. So both of these objects are books, right? Over here in this book class, I defined the book data type. I basically told C# like, hey, we got a new data type. It's a book. It's awesome. All books have a title, an author, and a number of pages. And over here, I created individual books off of that blueprint, off of that template, right? So book one is its own book. It has its own title, its own author, and its own pages. Book two down here is another book, and it has its own title, its own author, and its own pages. So if I was creating an application for like a library, for example, let's say the library had 10,000 books. Well, I could create 10,000 objects, all of which would have the title, the author, and the number of pages of each one of those books. And then I could work with those books. I could pass them into methods. I could use them in if statements. I could do all sorts of stuff with those books, just like I would with other data types like strings, numbers, or Booleans. So classes and objects are extremely powerful. And really, this is just scratching the surface. This is like lesson one. You know, this is the bare basics of working with classes and objects. As we go forward for the next few videos, we're going to learn all sorts of ways to make these a lot more powerful. Hey, thanks for watching. Hey, welcome to Draft Academy. My name is Mike. In this tutorial,
I'm done. I'm gonna go get ready for bed. I'm now at where I've last left off. I'm gonna try to do like the next day. I'm just gonna try to do all the rest of this, and because I want to get back to Unity. It's been like 2 to 3 days of me off Unity, like off game development, more focused into whatever the fuck, C sharp. But I need to fix my game manager, and this is really the main reason I need this. Because my game manager fucking. Two string. This is an int score to string. Oh, I see. Score text. This is a text. Why can't I just make this a string? Oh, because this is. Oh! Oh, because this is a text. What the fuck did he call it? Hold on, I'm retarded. I need to.
Hey, welcome to Potter.
Look at this bitch.
Console.writeLine, and over here, individual books off of that blueprint, off of that template, right? So book one is its own book. It has its own title, its own author, and its own pages. Book two down here is another book, and it has its own title, its own author, and its own pages. So if I was creating an application for like a library, for example, let's say the library had 10,000 books. Well, I could create 10,000 objects, all of which would have the title, the author, and the number of pages of each one of those books. And then I could work with those books. I could pass them into methods. I could use them in if statements. I could do all sorts of stuff with those books, just like I would with other data types like strings, numbers, or booleans. So classes and objects are extremely powerful. And really, this is just scratching. Change it to book two. And then finally down here, so the first thing I'll do is specify the book is. I basically define the book data type. I can actually do that. And I can create.
This is data type. The book data type. Alright, well, soon come. Tomorrow we'll try to finish all of this off, the rest of this course, and get back to full steam ahead Unity. It's only 10 minutes, say 20 minutes, 30 minutes, 40 minutes, 50 minutes, take about an hour. So I need to give myself an hour tomorrow